CSC420 final project, Deep Learning for Human Emotion Recognition.
The dataset we use is CK+, which is a common dataset for classifying human face emotions. There are 327 labeled images from the videos in total, but we only take the last 3 frames of each labeled videos. So we have 981 labeled images as our dataset. There are 7 types of emotions in total, and the goal of our project is train a deep learning model for emotion classification.
This is our approach to solve the problem. Data preprocessing. We do the following to each image in the dataset. First, crop the image according to the face position detected by OpenCV. Second, apply subsampling with Gaussian pre-filtering to get an image of size 48 × 48. After this, we transfer the images into tensors and feed them into the neural network and start training. The residual neural network we use is proposed by a paper, and we have the reference to this paper at the end of the presentation. It has a convolutional layer at the beginning, followed by a max pooling layer. Then it has 4 residual blocks with max pooling, followed by 2 fully connected layers with ReLU activation. At the end, it outputs a one-hot vector. Originally, the residual block in the paper uses average pooling at the end of the residual block. We changed it to max pooling because it can bring more nonlinearity into the model to make it more powerful.
Instead of classifying emotions directly, we divide the dataset into easy and hard, and here's how we do it. We first shuffle and split the dataset into 7 parts. We use the first part as the validation set and the rest of 6 parts as the training dataset to train the first model. And we use the second part as the validation set, the rest as the training dataset to obtain the second model, and so on. So finally we get 7 models. And we repeat the above 2 steps for 5 times and get 35 models. We run the 35 models on the training dataset and count the number of wrong predictions on each image. If an image is ever predicted incorrectly, we label it as hard, otherwise we label it as easy. Now we have the image and the label of hard or easy of this image. So according to this, we train a KNN softmax model to distinguish the image belong to hard class or easy class. We then use our KNN classifier to classify images into easy and hard. We train a model easy based on easy images only, and we train a model hard based on hard images. And then we combine the 2 predictions to produce our overall result, which is much more powerful than using only one model.
The next section is to evaluate our model and plot the confusion matrices. The confusion matrix on the left is achieved by our final hard and easy models. As you can see, it has a 93.3% accuracy on the testing set. In comparison, if we train only one residual neural network to classify the emotions, it can only get an 85% accuracy, as shown on the right side. As we mentioned earlier, we changed the average poolings in the residual neural network into max poolings to make the model more powerful. As a result, the model's accuracy on the testing set increased from 86.6% to 93.3%. We also added ReLU activation after the last 2 fully connected layers. It also increased the performance of the model.
In this project, we have covered 3 topics in the course. The first is image preprocessing. We subsample with Gaussian prefiltering. The second one is deep learning. We do training, testing, k-fold cross validation, and build models. The third is image classification using KNN softmax, which classify the image into easy and hard. We develop our roles into following. Ray is responsible for data preprocessing, ResNet, and KNN classifier. Lawrence is responsible for implementing k-fold data generator and training testing architectures for models, model evaluation, and plotting confusion matrix. Thank you for watching. And this is the reference to the paper.